Hello, in this video we're going to have a look at the specific expansion technique of expanding a perfect square. And the thing you need to develop over time is seeing a problem and noticing, I suppose, that it is a perfect square. And then once you've noticed that, using that or the rule for perfect square in order to expand it efficiently rather than always going back to the box method or the chicken beak method to do an expansion, which you should be able to do in one step instead of two or three. That's the gold standard. So practice identifying a perfect square, practice identifying, then practice applying the rule once you've identified it. So let's have a look at the perfect square. Now, normally, if this is the first time you'd ever seen perfect square, or in the next video, difference of two squares, I'd be going through why it works, why the expansion works as it does. I won't be doing that in this video, but if that's something that you think would you need to see because you've forgotten it, then ask in class and I will show you why it works. I find if you can construct meaning out of these rules, you're more likely to use them more effectively in the end. So don't just try and memorize rules because you tend to make mistakes as a result. Get me to show you if you're not too sure. Let's have a look at the perfect square rule then. We always start off with it being able to be written in this form, an expression to the power of 2. Doesn't have to be a binomial, but it works best if it's a binomial. If it's something other than a binomial, then, like a plus b plus c all squared, then it requires a couple of steps to get you there, but you can still use the rule. So it's either going to be in the form of something plus something all squared or something minus something all squared. Now do note that it could be simply written as an expression multiplied by itself, a plus b times a plus b, or a minus b times a minus b. So it'll either be written in squared form to start with, or it'll be what we call a repeated factor, the same thing multiplied by itself. Both of these things are square. That's what you need to look out for. Is it the same thing multiplied by itself? Okay, then if it is, then the perfect square rule says we square the first term and then we add twice the product, which means we multiply the terms together. So 2 times a times b, which is just 2ab. And then we round off with a squaring of the second term. Now you need to get used to following this pattern exactly. The first term might look complicated. The first term might be a, it might be x, it might be x cubed, it might be the square root of 7. It doesn't matter what it is, that takes the place of a in each part of this expression. And then the second term is squared here on the end and forms part of the product in the middle here. Get used to it. If we have it in this form, it is exactly the same. I don't want to see you using chicken beak method. I don't want to see you using box method. I want you to be going, oh yeah, I square the first, and then I add 2 times the two terms in the middle, and then I finish off with plus the square in the second go. Okay, if it's a minus b all squared, it's almost exactly the same. We square the first, we follow the sign through. So because it's a minus b, we go minus 2 times a times b, and then we add, note add, when we square something, it becomes positive. We square the second term. So it's a squared minus 2ab plus b squared. A minus b times a minus b, it is the same thing. It is a repeated factor. It's a minus b multiplied by itself. Square the first, minus 2 times each of the terms there, so 2 times a times b, and then minus b times minus b is plus b squared. And so, again, what you're looking for is applying that exact rule across a whole bunch of different problems. I'm going to go through a couple of examples now, 3 examples, but honestly, no, 2 examples for this set, but honestly, you just need to practice lots of different kinds of examples until you really get a feel for this is a perfect square, this is what the 2 terms are, and this is how I go. All right, let's have a look at example 1 here, which is really straightforward. You've probably seen this since year 9, so I won't dwell on it too much other than focusing on recognizing the expression and then going for it. So we see that it is 2 terms which have been squared, okay? And so A is x and B is 3. And so the expansion is a squared, A is So you mean this is what you do in your head, really. You're saying A is X and B is 3. So we go A squared, so that's X squared, 2 times A times B. So 2, how about I write it in for this one, even though you should do this in your head. 2 multiplied by A, which is X, multiplied by B, which is 3. And because it's a subtraction here, we put a subtraction sign in here as well. So the sign follows down. Plus B squared. So that would be 3 squared. Okay, so again, once you're practiced at it, which might be already, you wouldn't bother doing this line. You do it in your head, basically. But you need to get to the point where you're practiced with it, okay? And then we just tidy up. X squared minus 2 times x is minus 2x multiplied by 3. We just multiply the numbers together, right? So 2 3s are 6, and then we've got an x. So minus 6x, and then we've got plus 9. So what I want long term is for you to go from x minus 3 all squared down to x squared minus 6x plus 9, and you're done. So in your head, you're going 2 times 3 times x is 6x, put it down. 3 squared is 9, putting it down, and having your operations as necessary. Example 2 is a little bit more complex, right? It's written in repeated factor form instead of just as a square. You don't have to mush them together. You can go straight to the final line next. And again, you should be doing some thinking in your head. What I suggest you do, you don't have to, but what I suggest you do is pause the video right now and have a crack at it yourself. You can see I've done it in 2 lines. You might be able to do it in 1 line if you're good enough. Maybe you don't know how to start, but give it a crack and then play the video from that point. Okay, either you just cheated and didn't pause, or you have had a try. Doesn't matter if you didn't get it right, as long as you've had a crack at it, I'm really happy. Okay, so again, we're not going to use box method. We're not going to use chicken beak method. All we see is that we've got an x squared here and an x squared here. Great. Plus, right? Root 3 and root 3 here. Okay. So we have the form of a perfect square. We're always trying to identify these patterns because using the rule is a lot faster. So I square the first term. Now, because this is complicated, I'm going to go in 2 lines. So squaring the first term is x squared squared. And then it's twice the product in the middle. So I'm going to go 2 times, I can see in my head, it's going to be 2 times x squared times root 3. So in my head, I'm sort of going, a is x squared, b is root 3. Okay, so because of that, I'm keeping it a track of what I need to do next. So I know I need to multiply those 3 things together. So I'm going to go 2 times root 3. It's not root 6 or anything like that. Root 3 is if you remember, it's a surd. It's a value that doesn't have an exact answer. And so I've got to leave it as root 3 to be exact. So I'm going to go 2 root 3 x. Whether you put that little bar over the top of the 3 or not, it's up to you. You can see I've done it here, but not here. Both are acceptable. So 2 root 3x, and then I've got root 3 squared, which I'm just going to take an extra line to do. So I've got root 3, and then I'm squaring that as well. Now again, once you get really proficient, this line may be optional. Okay, to increase your efficiency, but as long as it's only efficient if you're going to get the final answer right. So if you're not confident on it, definitely spend the extra time doing that middle line to make sure that you don't make any mistakes. So x squared squared, you might remember from your index laws that you just multiply those 2 indices together to get x to the power of 4, or you might just use your logic, x squared times x squared must be x to the power of 4. In the middle, we've got 2 root 3x, which we'll keep as is. And root 3 all squared, root 3 times root 3, I'm hoping you'd remember that if you square a square root, they're kind of opposite operations, so they undo each other. And so we're just left with a plus 3 on the end there. Okay, so a more complex example, but ultimately, it's just a following through of the rule. Now, one final piece of advice, then I'll leave the video here for today. It may be that if you're not used to doing perfect squares, or if you're not used to doing more complex perfect squares like example 2, you are probably going to feel like doing the box method or chicken beak method is easier because you make less mistakes and it's a pretty basic method to follow. That's probably true. But like anything, it always feels harder at the start when you do something you're not used to. But with practice, you gain fluency, and with fluency, you gain efficiency. So even if you know right now that the box method or chicken beak method would be faster to solve a problem like example 2, try to stop yourself from using that. If it fits the perfect square model, use the perfect square rule. Trust me, with practice, it'll be a more efficient method. And it encourages you to think mathematically because you're moving beyond a simple basic method like chicken beaking or box method to actually looking beyond a problem to see that it fits a pattern and understanding how that pattern fits a rule. And that's a much deeper way of looking at mathematics. And as we sort of continue on our mathematical journey, particularly if you're going to do methods 415 next year, say, for example, you'll really appreciate this sense of being able to see past the surface of a problem to look at the underlying patterns underneath. Okay, I'll get off my soapbox. That's it for perfect square. The textbook has some perfect square work in it. So you might want to have a crack at that or move on to the difference of two squares video before having a go at the whole lot.